Okay, hello everybody to a new episode of the Solar Journey. And today we have on board Charlie Gay, a living legend in the PV business. Hi, Charlie.
How are you, Torsten?
Good, thanks. Good, thanks. So let me just tell you who Charlie Gay is if you don't know. I guess most of you do know because, as I mentioned, he's been in the PV space for a very long time. Currently, he is the president of Galaxy Energy, company based in California, but also in the US, but also in China. What Galaxy does, we will learn later. But just as a teaser, it's about magnesium, electrodes, and energy storage. Yeah, so if you have been in PV solar for some time, you do know Charlie Gay. And if you still don't, then it's about time. Here's why. He has over 45 years experience in renewable energy. He has significant private sector experience. For example, he was the president of Applied Solar, the business unit of Applied Materials. He was chairman of the technology advisory board for Sunpower. And he was president and chief operating officer of Siemens Solar and president of ARCO Solar. Charlie was also in the public service space. So he was director of the Department of Energy's Solar Energy Technology Office. And he was the director of the National Renewable Energy Laboratory, or NREL, in Colorado, USA, which is one of the oldest and most well-known solar energy institutes worldwide. But he's also the co-creator of the Green Star Foundation, an organization that delivers solar power and internet access to villages, scaling micro-enterprise in the developing world. Yeah, and so by training, he's a physical chemist. So he's got a PhD in chemistry, and he holds many patents. And his first peer-reviewed paper dates back to 1966. Yeah, and he also got plenty of awards. So, for example, the US National Academy of Engineering. So he was elected to the US National Academy of Engineering. And he won the Charles Greeley Abbott Award of the American Solar Energy Society. And lesser known, he was also key in getting LED flashes into the solar cell market in more detail. It took him 5 seconds to make sure that my own company, Wavelets, got to the initial seed investment. I'm not sure, Charlie, if you are aware of this. Yeah,
No.
You're not aware. Yeah, so it's almost 11 years back. That was at the PVSec conference here in Hamburg, Germany. And I approached you back then and I said, hey, Charlie, in a few minutes, I've got a guy coming with me, and Jörn Sutus, the co-founder or the originator of Wavelabs. We want to get his money so he does the initial seed investment for Wavelabs. So we returned, and you saw us at the Applied Materials booth, and you opened up your arms and said, I love those guys. And I think that's and I think that's when our senior investor, Herr Hülsmann, had no chance then to give us the millions and billions of these dollars to get Wavelab started. So thanks a lot again for this. But anyhow, I think but I think your other achievements are even larger that I lined out up front. Yeah, so Charlie, when did you get started in solar and why?
I got started in 1974.
Yeah.
It was right after the first oil embargo, which was October of 1973.
Yeah.
And I had gotten my PhD working on the thermodynamic properties of fluids near the critical point and studying heat capacity and the effect of compressibility on these fluids. It's something that doesn't have much of a connection at all to photovoltaics, But it turns out it does have a connection now, finally, 45 years later, to the concentrating solar field where people use supercritical CO2 for the working fluid rather than steam. Anyway, long story short, I'd gotten my degree, PhD, I went to look for a job. And the only job that really could make any use of how I spent so much time getting my PhD was injecting steam or CO2 in the ground to get more oil out of the ground.
Wow.
And I had an interview in Bartlesville, Oklahoma, which is kind of an isolated, remote area where Phillips Petroleum had their headquarters, and they offered me a job. But as I was thinking about it, and on my way back to Los Angeles, where I've lived most of my life, I ought to look and see if there's something else I could do. And I picked up the Sunday edition of the Los Angeles Times and looked for jobs. One of them was an advertisement from Spectro Lab for somebody to weld solar cells together for satellites and make them more resistant to laser attack and melting of the interconnects. So I rewrote my resume a little bit there to highlight what I knew about metallurgy and materials, and went for the job interview at Spectro Lab and was offered that job, figuring out how to weld solar cells together. About 3 or 4 months after I was at Spectro Lab, my boss said, you know, I probably should tell you why we hired you. I said, oh, by all means, I'd be very keen on the feedback. And he said, well, when you came, it was clear you had the technical knowledge, but you were wearing an orange pair of pants and a polyester shirt. And we figured if you didn't know the technical stuff, you'd be quite entertaining anyway for the rest of the group. And part of that's because I'm colorblind. So,
oh, really? Okay.
that ended up working out well. The task of welding was a 2-year program that had been funded by the Air Force. And it maybe took 3 or 4 months to figure out how to set up a parallel gap welder and weld solar cells. And my boss said, you can use the rest of the 1.5 years, just follow the materials around Spectro Lab, learn the processes, whatever you'd like there. It went all the way from Czochralski growth of silicon to assembly of the power systems for communication satellites. So I got a chance to learn crystal growth, wafering, solar cell making, design of power systems from the people who really knew what they were doing there. And that has served the foundation of my knowledge base from that point forward. I joke with people, but I haven't had to learn a whole lot more since I did that. And I was very glad. It seemed like solar would be a possible path to address the impact of the oil embargo. And it was a field that was material science oriented. I was interested in it. All the ACE students were becoming nuclear engineers and building nuclear power plants. So the competition wasn't so much either. So that's how I got started.
Excellent, excellent. So basically, Spectral Lab was today we would say a vertically integrated solar cell manufacturer. If they started on, well, except for this feedstock, but then they had everything in-house from crystal growth to modules.
Yes.
Cool. And it was all mostly for satellite application
Yes, it was almost all except for beginnings of a terrestrial solar program. At that point in time, NASA had set up 3 ground-based large antennas to communicate with spacecraft as they were orbiting the Earth. One was here in California, a place called Goldstone, which is out in the middle of the Mojave Desert. One in Australia that shows up now and then, not too far outside of Canberra. And then the third one was in a very rural, isolated area of Nigeria. The people were quite poor, and the program was led by the NASA Lewis Research Center in Cleveland. And they came to Spectral Lab and said, you know, we would like to be able to do something to bring electricity to this rural village. And maybe an application besides lighting that would work well is to grind the husks off of rice. So part of the project that I worked on after welding cells was working with a team looking to get cost out of the solar cells in order to power this rice husker in Nigeria. And NASA could exchange, you know, some improved infrastructure for the rights to put the antenna on their land. And that's really a lot of how some of the early work at replacing vacuum deposited metals or electroplated metals for contacts, evaporated tantalum pentoxide for AR coatings, with much lower cost approaches towards processing, metallization, damage removal, texture etching. At that point, the actual chemistry of what enables texturing to occur was puzzling to everybody. And so I had a chance to work on some of those kinds of things, and also to see the benefit of the impact of solar in this rural community in Nigeria.
Yeah, wonderful. So from satellite space to terrestrial, one of the early terrestrial applications. What was the efficiency back then for the satellites, or back then for the Nigerian application?
For the satellite side, I had a project to see how efficiency varied with thickness. Yeah. And so it's actually where the first, I think the thinnest solar cells I made were about 35 microns thick, silicon. Okay. And they were about 16% efficient, and at 150 or thicker, they were a little more than 18% efficient cells. Okay. Yeah. And the terrestrial modules with the lower cost metallization and the sort of glass front packaging were around 10 or 11% efficient. And that was sort of a broad span of activities. The management of Spectral Lab changed from a company called Textron, which was a conglomerate of everything from Bell Helicopter to other businesses, to Hughes Aircraft. Hughes wanted to have its own in-house solar cell satellite, communication satellite capabilities. And when Hughes came and took over Spectral Lab, a lot of the people I worked for lost their jobs to longtime Hughes executives. That happened to occur in 1977. And in 1978, the second oil embargo took place. And most of the guys who left Spectral Lab started terrestrial solar companies. And I joined a fellow named Bill Yerkes, who was one of those folks to leave Spectral Lab. He had been president of Spectral Lab, and he started a company called Solar Technology International with, about 6 or 7 people, half of them from Taco Bell nearby, who are making tacos and burgers, to start making solar panels. And when the second oil embargo took place, almost every oil company under the sun wanted to diversify into high tech. Atlantic Richfield was one of those and started ARCO Solar. Shell, Exxon, Mobil, Total, Showa, they all had initiatives to get involved in high tech and manufacturing, which is a very different kind of business than the oil and gas business. But they brought a lot of not just long-term consistent financing to support the early startups, but a lot of the know-how for the encapsulation and packaging. So coming European PV conference, the folks in Switzerland who have had some of our modules from ARCO Solar, the first grid-connected system in Europe was installed in 1982. They're reporting on the 40-year results for that system. And we had 3 different encapsulant systems in the modules. The best of the 3 is producing 95% today of what it did 40 years ago.
Oh, wow. Yeah.
The worst one is about 85%. Okay. So we have this fabulous existence proof that we know how to design something that will last the length of life that a power plant needs to last, or longer, more than 40 years here. Yeah. And of course, that's the springboard for bankability, for project financing, when you can project what the cash flow is going to look like because you know how much power to anticipate being generated.
Yeah, yeah. So let me just recap. So from Spectral Lab, you moved on to ARCO Solar?
Yes.
That was the next, okay.
Yes, I was hired as to run R&D, manufacturing and engineering at ARCO Solar, and mainly to staff up the company. And I spent almost 10 months trying to recruit somebody to come and work with me in this crazy solar business. And people who are getting their PhDs and advanced degrees, as I mentioned, went to RCA, to Bell Labs, to General Electric, to Siemens. And after spending that 10 months trying to recruit somebody, my youngest brother was just graduating from MIT with a PhD in inorganic chemistry. And I went to see him and I browbeat him into joining me. So I had my second R&D employee to work in solar. Then his job was to go recruit people to come and join this crazy industry. At that time, it wasn't an industry. So people leaving school saw solar as a very risky career move. But, you know, looking back and thinking about it, the best time to take a risky career move, and you can probably speak to this as well, is while you're still young and you don't have a lot of children, and you have other responsibilities to occupy your brain cycles every day. So the buildup of ARCO Solar by the end of 1980, we manufactured 1 megawatt in 1 year. And of course, you think today, 1 megawatt is a little less than an hour in a lot
today's
of
dimensions,
facilities. And in 1982, as I say, we had our first grid-connected system in Europe. And in 1982, we had our first 1 megawatt power plant connected to a Southern California Edison substation in the transmission system here in California. And the chairman of Edison, Bill Gould, gave a really nice speech talking about how his predecessors in the utility industry spent 100 years putting up wires, and his successors in the utility industry wouldn't have to worry about putting up more wires because they could put the power close to where it was needed.
Yeah.
So a lot of the visionaries that we benefit from today came out of the oil embargo times, came out of the times of need, and we're sort of in a similar situation of climate change, needing to attract people to take a risk to mitigate the risk of climate change.
Yeah. Interesting. Hey, by any chance, do you still know who built the inverters for those very first grid connected systems? Because this must have been also like prototypes, or could you rely on previous
they were
products?
the company that there were two major suppliers. Neither one of them is still in the business today. Both of them were acquired. One of them is still operating as part of Siemens power business.
Okay. Yeah. Fantastic. So from ARCO Solar, what was the peak time? How many people worked at ARCO Solar for this 1 megawatt a year? Crazy.
We had probably we not only we grew crystal, wafers, cells, modules, and built power systems.
Yeah.
So it was, and we also developed water pumps, battery storage designs, all of the things that we take for granted that, today you could go to Grenfos for a solar water pump.
Yeah.
But in the beginning, there weren't the right pieces of equipment to go with the output of the solar panel. So in 1982, we had about 600 employees.
Okay. Cool. And then from ARCO Solar, where did you move next?
I went to the National Renewable Energy Lab.
Okay.
So the NREL got its start also because of the oil embargoes, and Jimmy Carter was president. And the lab has its start in 1978. Maybe it was October 77, somewhere right around the turn of the year. And the lab did well during Carter's period, followed by Reagan, who chopped the budget in about 75%. So when I was brought to NREL because I had experience in industry, putting business objectives in place and dealing with the outcome of the election here in 1994, where there was a contract with America that also targeted cutting investments in R&D and renewables, and NREL's budget was cut by a little more than 30%. There were about 1,000 employees at NREL in 1994 when I got there. And so if we were to just take a straight ratio there, that would mean 300 people would lose their job.
Yeah.
So had a chance to sort of restructure a lot of the way business was carried out at NREL to streamline overhead. And at the end of the day, I think I laid off maybe 45 employees instead of 300.
Oh, wow.
And started what was called the Industry Growth Forum, which was a venue to bring venture capital in to meet the people at the lab and the industrial and academic teams who were contracting with the lab to carry out research and applied research and development programs. And that program, the Industry Forum, still is going. This year, I think, has probably been close to 42 of these fora, but there's a lot of the networking that got started where investors could meet and learn more about the technologies and could see sort of over the horizon what technologies were coming, could participate in helping invest in startups.
Yeah.
So that was a lot of the experience at NREL was linking more strongly with the finance community and industry.
Mm. Yeah. Okay, so how did you put up with moving from Los Angeles on the coast to Colorado, to the mountainous people?
Well, like Colorado is absolutely lovely.
Yeah.
The snow sort of sublimes off of the ground, so
Yeah.
it doesn't form big blocks of ice that are filled with mud. It's one of the best living experiences I've had.
Yeah.
It's very outdoors oriented. There's a lot to do all year long.
Yeah.
And Coors Brewery is based right there where NREL is for a good reason.
Yeah. So you started skiing, and I don't know, maybe you switched from surfboard to skiing, I assume.
And when I was in college, I actually met my physical ed requirement surfing every Thursday, so, rather than going to class.
Yeah, excellent. All right, so NREL, how many years did you spend at NREL? And
4.
4 years, yeah, all right. And then what was the next station where you left your footprint?
Yeah. 2 things. I started the Green Star Foundation.
Yeah.
To essentially bring information and energy together. So we went to rural villages that didn't have electricity, but they didn't have internet either. And sort of set up community centers with solar power and spread spectrum modems that could link the village to an area that had some copper infrastructure. So that we created what we called digital culture. Went to the village, recorded the music, art, stories, poetry, and I came back here to LA and licensed a lot of it to Disney. The royalties from the licensing of the culture, of the music, went to the village. It helped preserve the traditions and the history of the village, of course, but then the village had capital to create microcredit structures, banks, that would fund entrepreneurs in rural villages. And they could use the internet access to identify markets for when the best time to bring a harvest in, or bring coffee beans in, how to maximize the quality of tomatoes or bell peppers, other crops for international export, because they had information and they had their own liquidity, their own capital based on their culture.
Yeah.
So the next thing I did was scale this. It was a result of looking at most of the multilateral development banks, the World Bank, Asian American Development Bank, had capitalized funds intended to help support solar and renewables in rural areas. But for a rural villager, if you were to access that money, you were required to show how you would repay the money with currency risk and with the interest rates of a rural village, which are 40 to 70%. And so a rural villager couldn't qualify to receive a loan. So and so the money was sitting at the World Bank or the International Finance Corporation, the private equity arm of the World Bank. So this idea of Green Star was, how do you start business in a rural village when you have nothing, but you have a lot based on the culture and history and the music of the village. And when I would go to a village, I would usually have with me a laptop, a satellite phone, and a solar panel. And I'd go to visit the theater arts department of the university that happened to be closest to this isolated area, to get a theater arts major, a mime, to come with me to the village. So I would use no spoken words when I got to the village, and the mime knew the local language, the local dialect, could help translate questions that came, and we would act out, say if in a rural Indian village where we did this, the children are the ones who catch on first to what's going on. They wanted to know about the soccer game or the cricket test with Pakistan, and found that they could get the information because they had some energy that could run the equipment to have a computer with a link to the internet.
Yeah. And
much of what is possible today is also about connecting information with energy. And it's part of what I'm doing in my current venture at Galaxy Energy. Getting to sort of the end game here, where our energy networks run autonomously without people needing to intervene into how the network operates. And we have a pilot underway. Galaxy has a 50-50 business venture with China, with some folks in China. And we're operating in Shanxi province, more or less the middle central section of China, where I spent most of my time while I was working at Applied Materials, because our customers for equipment were almost all in China. At one point, by 2010, we had over 200 customers, unique manufacturers in China, buying our Bacchini screen printers, wire saws, and we set up a solar R&D center in Xi'an to support folks all across China. And when I was there, the governor of the province asked for me to help electrify every unelectrified village in Shanxi province. And I said, if you have the army loan me the helicopters, we can get to every village and electrify more than 2,000 villages that didn't have electricity. We did that with solar in less than 1 year.
Okay,
so
wonderful.
The ability to bring people together to work on things. We have an initiative to couple solar power with smelting of magnesium ore to make magnesium. It's in a area called Fugu County, where the Yalu River runs about 150 kilometers through that county. So there's a great pumped hydro opportunity with the Yellow River there. I've been using Andrew Blaker's pumped hydro maps to line out where we can have 24/7 power, all solar, upgrade the metal making, since it's sort of where the world is today, solar, wind, those are electricity generation. So we're working on maybe a third of the energy consumption, another third is transportation. So electric vehicles are helping clean up transportation. And the next big nut to crack is cement, steel, metal foundries. So we're working on a metal, magnesium, which can be useful in reducing weight in the transportation side, but it's a great hydride material for storing hydrogen.
Yeah.
So we have a system to solar, pumped hydro, to deliver power 24 hours a day, and the relationships are there because there are so many dams along the Yalu River already that the links with the utilities are working.
Yeah.
And we're producing magnesium that's used to reduce the weight of lithium-ion cells, and it's used to reduce the mass of the housing. A battery is like a solar panel, the cell is the heart of it, and then the packaging of a cell calls a battery. So a battery, lithium-ion case, a lot of the designs are moving from small diameter cylinders to long, narrow rectangles that shorten the distance current has to flow to get to the terminal. And then the housing of the rectangle is made in our prototypes here of a magnesium alloy. So we're getting a lot of the weight out of the lithium-ion cell and out of the lithium-ion battery.
Yeah.
So with the sort of the network here of bringing solar, pumped hydro, producing magnesium for applications that are relevant to transportation.
Yeah.
And at the outset, it turns out that not only does the Yalu River cross Fugu County, but also the major transmission system that runs from west to east in China crosses Yalu County, and the major gas pipeline crossing China goes through Yalu County. So we're working with sort of the blue version of converting natural gas into hydrogen and then propane, butane, longer chain, LPG, liquid propane feedstocks, so that we have more hydrogen generated from the pipeline and can use that with the magnesium being produced as a hydrogen storage medium. And we have a catalyst, magnesium oxide-based catalyst that can also help catalyze the conversion of methane to propane and extraction of hydrogen. And of course, if you just throw magnesium in water, it splits water into hydrogen and makes magnesium oxide, which is useful for construction materials, wallboard, in some concentrations to improve cements. So the goal is to have an autonomous energy network demonstration of somewhere around 30 to 40 magnesium metal smelting facilities in Fugu Province, County, being linked to getting their electricity from solar and from pumped hydro used by generated from the solar, and working with some of the early opportunities of hydrogen, which can, of course, just be injected up to 15, maybe 20% into a natural gas pipeline without making major changes to the infrastructure. Mm. And by moving to LPG, moving to propane, you turn the greenhouse gas potential of methane, which is like 25 times or so CO2, into having almost zero greenhouse impact from propane and from hydrogen. Oh, so okay. We have a project to make this network autonomous, that the energy flow can be essentially operated in a microgrid format, which makes it much more resilient. And with the software systems that some of the collaborators I worked with while I was at the DOE, developing the algorithms for smart grid autonomy. So the information and energy convergence that I worked on in Green Star for rural village electrification, we're bringing to a county in China to demonstrate how much carbon reduction potential can be practical and cost effective here. Yeah. And continue to scale the adoption of the clean fuels, electric vehicles, and of course expand more PV.
Yeah. Hey, so and at the center for your company you work for now, it's magnesium. It sounds like a magic material which can be applied in so many interesting ways for energy storage. Is that a newcomer, that material in the renewable space, or is there other companies working on the application?
The application first shows up in vehicle weight reduction, so sports cars in
for the
Formula
chassis,
1 racing.
Yeah. For the chassis,
so
yeah.
You can make magnesium alloys with aluminum and zinc are the primary alloy additives, where you have anywhere between 3 and 8% aluminum and a few percent, maybe 3 to 5% zinc. You can make structural materials to take weight out of cars. So magnesium has quite a long history for aircraft and for racing cars. Yeah. And the materials, I think, with the background I had in materials going way back, it's just a really interesting material, both for the networking with renewables, and one of the areas of interest I also have is in superconductivity. Magnesium diboride has a superconducting transition temperature of around, 37, 38 Kelvin. It's relatively high for metals that are used in superconducting. So there's some applications that, are long-term, but are also interesting that could help with energy efficiency. But at the moment, we're just looking to demonstrate this autonomous energy network. Usually, the operator of an electric grid is different than the operator of the gas pipeline, and the owner of hydro generation facilities sometimes is linked to the electric grid, sometimes not. If we could bring together the stakeholders, where the load here is the smelter, and the industry in China today, if the amount of pollution being generated to produce electricity, mostly from coal, trips a threshold, steel mills are the first things to be shut down, metal fabrication facilities closed down. So we're out there on that third sector of industrial scale, cement, steel, metals, to help them become cleaner. And they're long entrenched industries that don't have a history of changing. So that, a CEO at a steel company may be there for 30 years or 40 years, and it worked 30 years ago, so why change it? So the opportunity is here. Interestingly enough, because of the roadmap for going to zero carbon by 2060, and because China has a regular 5-year planning cycle, they have an ability to do long-term planning to get to the objective. And so part of what we're doing here is enabling financing from global sources and enabling the link up of know-how for how do you bring the autonomy to bear. So a lot of work that the National Renewable Energy Lab does now, Pacific Northwest Lab, Oak Ridge, Sandia, Argonne Labs, is all, it links into grid operation and looking at autonomous microgrids connecting into the electric grid.
Yeah.
And what we're doing is extending that to include gas and to include teaming with the load centers like production of magnesium in this case.
Yeah. Give us an idea, who is Galaxy Energy, or I think there's a mother company. How many people and what's his history?
It's part of a group called Asia Pacific the Trade and Technology, Galaxy Trade and Technology,
yeah,
which has been around for a little more than 3 years.
Okay.
It's a 50-50 venture with some Chinese companies and businesses. And Galaxy, my partners are based in New York, Geneva, and Honolulu.
Mm-hmm.
So we have a network here across the US, but it's mainly the financing network across the US and Europe.
Yeah.
And the technology implementation group in China for putting these pieces in place to demonstrate what we can do with a smart utility network of gas and electricity.
Okay. And all in all, so how many people work in China for Galaxy?
Oh, there's a little less than 50 in China.
Yeah.
And a little less than 24 here across the US and Europe.
All right, excellent.
Just beginning.
Yeah, all right. And the focus is not really the casing for lithium-ion batteries, but it's really more on the smart grid software side. Or
there's some immediate opportunities to take weight out of a lithium-ion battery.
Okay.
By replacing the copper anode with a magnesium electrode.
Yeah.
That has a surface treatment that gives it the same chemical properties as copper has in a lithium-ion cell.
Okay.
So we get a big chunk of weight out of the cell by substituting magnesium, a low-density material, for copper. And we get weight out of the housing 2 ways. One, because it's mostly a magnesium alloy for the housing, but it's designed along the lines of what BYD does in China with what they call a blade design, a rectangular cross-section that brings torsional stiffness. And part of Galaxy's network, we have Galaxy Transportation, is a team of people who comes from the race car industry. So integrating the structure of the battery housing into the structure of the car, you can reduce the weight because the function of stiffness can be provided both from the housing of the battery and the structure. Today, people just drop little round cylinders in a box and put a cap on top and on the bottom, but that's not a structural unit, it's just a box. Yeah. So use the strength of the housing, and the design is convenient because you don't have to have active cooling. And you can do quick recharge without active cooling as well. So there's a number of benefits to this thought process of how to hybridize the benefits of lightweight on the battery and structure side.
Yeah. So how much is the weight reduction potential for magnesium for the lithium-ion battery when you replace the electrode and the case?
It's at the outset, it's a little under 20%.
Yeah.
There's a meaningful initial opportunity for weight reduction because copper is the heavy hitter, so to speak, in the cell. And this can work without needing the weight and without the cost of copper.
Yeah. And when you mentioned when you use the battery as a structural component of the total car, so what can you still replace the battery without?
Yes,
that
the batteries
car falls apart?
Yeah, the
just for the
batteries
dynamic load,
fit into it's kind of like the way single axis trackers are designed with a torque tube. So think about being able to swap out torque tubes on single axis trackers. You can swap out a torque tube battery.
Okay.
That's bringing the stiffness. It's actually easier in the battery case, but because it's not clamped to big wings of solar panels, but it's the structural advantage of the single axis tracker designs built around, the difference between having a round cylinder or a square cross section tube for a single axis tracker. There are trade-offs that you can make. Take that same thinking, it doesn't map one for one with the functional need, but the mechanical property side, all of the know-how exists for running models of the strength of the materials in the configuration options that are available. Yeah. And they're readily replaced within the assembly that's the receptacle for the battery. Mm-hmm. And it serves as where the termination automatically latches plus and minus links into that receptacle easily. Yeah.
And another thing you mentioned was the circular design of battery cells and the blade design of BYD. So first of all, is BYD the only one who does the blade type design? And
they're I think the first ones to introduce it. And they license it without a royalty fee. It's a really good idea, and part of the history of thinking that batteries are round cylinders. We all carry that bag of old thinking every time we walk out the front door of our homes, and being able to think about the design in a different way opens up the nice spot. There's some great YouTube videos that BYD has produced showing the blade battery design that explains it far better than me trying to articulate it here without video.
Yeah, excellent. So we jumped a little from you being at NREL, now we are at Galaxy. So yes. we need to fill that gap. So you left NREL, you started Green Star, the foundation, and that's when, now the mid 90s or something, or
late 90s.
Okay.
And in the late 90s, I also joined Winfried Hoffman at ASE Americas. Previously Angewandte Solar Energy, based in Alzenau. And they were owned at the time by RWE, and then that piece of the business was acquired by Tessag, and ASC in Alzenau acquired the mobile solar business in Massachusetts.
Mm-hmm.
And so mobile solar became ASE Americas.
Okay.
So I joined working with Winfried and the team in Alsenau as part of joining ASE Americas. This was edge-defined film-fed growth. It was ribbon silicon.
All right. Okay.
Rather than single crystal cylinders. So the goal there was throw away less silicon as sawdust by making a ribbon. And the silicon was drawn through a graphite die to shape an 8-sided octagon, which had sides that were 100 or 150 millimeters to match the wafer size, one of the dimensions of standard wafers being used at the year 2000.
Yeah. Okay, excellent. And then, so ASE and mobile, we got that bridge. And where did you go after mobile?
I went to Sunpower.
All right.
And Sunpower was looking to get investors to scale interdigitated back contact cells. Pierre Verlinden had worked at Sunpower. Ron Mercord, some of the very, along with Dick Swanson, the founder of Sunpower, incredibly brilliant people. All had some common thread linked to Sunpower at some point. I joined Sunpower to work with Dick Swanson and his team to put the business plan together to get the financing.
So when is that? When did you join Sunpower?
2001, October of 2001.
Okay.
So during 2002, we were trying to raise money.
Okay.
And TJ Rogers from Cypress Semiconductor ended up bringing his financial horsepower to Sunpower. And we initially set up pilot manufacturing in Round Rock, Texas, just outside of Austin, where Cypress Semiconductor had a fab, an integrated circuit fab line. And the chips produced in Texas were shipped to the Philippines for packaging. So as Sunpower scaled, we ran a pilot line in Texas and then scaled the manufacturing in the Philippines. I think at that point, Cypress probably had 18,000 employees in the Philippines. So there were a lot of very good people to work with for the first factory for interdigitated back contact cells with Sunpower.
All right, excellent. And so this runs now as Maxion. So the Sunpower later kind of reorganized their business. And IBC solar cells are again on the rise, I would say. Still a small portion, but there's a continued interest and rising interest in the cell concept, but it dates back to a few years. So and then Sunpower.
Then I went to Applied Materials.
Okay.
I was hired. Applied Materials at the time was had been in the business, and still is in the business of providing equipment for the semiconductor industry manufacturing, and for the large area flat panel display manufacturing. And I was hired to set up a solar division at Sunpower in 2006. By that point, it was a lot easier to hire people into solar than 30 years before. And from between 2006, we went from having no business to selling over $2 billion a year by 2010. We went from 0 to over 2 billion in 4 years.
Excellent, amazing. So, and then after Applied, that's where did you?
Then I was at the Department of Energy
Okay.
running the Solar Energy Technology Office
Yeah.
for the US DOE.
Yeah. So you decided on which technology is worthwhile being funded. I assume that
Well,
that was
actually,
it.
the independent reviewers are the ones who review proposals of what work should be funded.
All right.
The job is more about defining categories for activity. So, like, lowering a solar panel cost, of course, is one part, but integrating solar into the grid is a big part of the work that's being done.
Yeah.
Tackling soft costs, all of the permitting costs and other costs associated with deployment of rooftop systems,
Yeah.
bringing solar to lesser well-off communities. Those are all themes that are important to the kind of work that's done at the Department of Energy.
Yeah. I just did an analysis on what my guests say, what is required to bring solar to the next level. And I mean, it's not a big population. It's I think back then it was 13 people, but anyhow, it was like more than 50% said that the key is to improve the regulatory section, just to simply to make it easier to deploy solar, right? To bring it onto the roof, to feed into the grid, just to get rid of all the, let's say, man-made obstacles. It's less about technology, costs, efficiency, etc., reliability. It's really more on the regulatory level.
Yeah.
Would you share that opinion?
I think even more important is consistency over time.
On the political level.
Yes,
Yeah.
because here in democracies, every time there's an election, the person who gets elected usually says the person before them had it all wrong.
Wrong.
So they change whatever was underway to their way.
Yeah.
And it's the source of major perturbation when you think what's the half-life of crystalline silicon technology? Well, maybe 30 years, 20 years. It's measured in decades. It's not like integrated circuits where a half-life of my laptop is 18 months. It's technology changes in the energy space, changes slowly. You need long-term consistent policy built around a strategy, a vision. And if that gets turned around every few years because of an election, it's very hard for anybody to reach the consensus for tackling climate change that we need to have, the sort of the common thread that all of us need to be addressing. And the best way we can find to collaborate and partner to get the momentum built and then to maintain it.
Yeah.
So even if it's not the best idea, if it's consistent, you can adapt to whatever crazy pieces there are in that equation, and figure out how to circumvent them, live with them, get around them, change the equation. But it's very hard when things change on a very short time horizon relative to the changing of an infrastructure that has so much capital already sunk into it.
Yeah. Excellent. Hey, and so DOE, and then from there, did you go straight to Galaxy, or was there something in between?
I spent time seeing if I could get a manufacturing plant built up here in the US called Violet Power.
Ah, right, Violet, right. Great.
And wasn't able to raise the capital necessary to carry that out. So I went from that. Serving on the boards, I help a number of universities which increasingly have entrepreneur programs. So students who have ideas for how to make businesses out of new technology. Older guys like me who have had a lot of experiences trying to solve problems can help, I think, in many ways, mentor students to navigate their way around problem areas and to navigate their way towards some successful new thinking, new ways of carrying out business.
Yeah.
So I've got work that I do with 3 different universities here in California.
All right, excellent. And if you don't mind, I would switch a little bit the topic, and because I think it's pretty interesting with your long experience as a businessman and entrepreneur. How do you pick new hires, right? I mean, you used to lead big teams, and you need the best talent, of course, always to get your ambitious technology projects solved. Now, looking back, what's your trick to get to pick the best?
Make sure they're not like me.
Okay, all right.
You know, you need somebody who thinks differently.
Yeah.
To push back, to get the best result by diversity of ideas, diversity of experience, diversity of culture. That's why I've really enjoyed Green Star, working in, I think, over 80 countries. Okay. With different cultures, figuring out how to communicate without words. Being able to adapt to common themes that all of us who are human share with each other, and come at it from different perspectives.
So how do you test in an interview that this person can push back and tell you where to go? Because at that moment,
there's some you can do, but it's the chemistry outcome. Even if you had the perfect interview questions, it's not going to extrapolate very far into the second week on the job. So a good example is one of the best technical people. It was on the solar team in Applied Materials, came from the organic PV background. And organic PV is interesting because it's so difficult to work with organic PV. You've had to deal with far more problems than a guy like me who's only mostly worried about silicon.
Crystal
single element.
Yeah.
And so people with that ability to bring some immediate benefit because they can help, they can understand aspects of a problem and can contribute right away in the organization, and then can bring that background of thinking from a different dimension into the organization. But my ability to interview people and predict doesn't have a very high correlation coefficient. It's usually just see what happens when you put the chemicals together and how that mix comes out.
Yeah. And another question around, let's say, running a tech company is, the classic thing is you have a target, you know, you want to achieve whatever 90% by using whatever a new element to doing the contacts. How do you meet the timeline, right? It's so hard to predict any technology projects, right? Because there's so many uncertainties, because you usually don't know the path how to get there, right? And at the same time, there's a business that needs to be fed with your innovation. So it's very important to meet kind of some timelines. How do you do it, right? Because I think it's one of the trickiest situations, right? Trickiest tasks. Yeah. Project management, predicting timelines. Yeah.
Pick one thing to measure. So one of my favorite stories is here in the US, around Pittsburgh area, Carnegie Mellon University, fabulous for automation and advanced technologies. They were originally endowed with funds from Andrew Carnegie, who made his money in the steel industry. When Carnegie retired from running his company, he was hired as a consultant, and he would go visit steel mills, and the plant manager would give him a tour, walk around. And a good example of the story is one steel mill that he went to visit. At the end of the day, the plant manager asked him, "What advice do you have for us to improve our steel business?"
Yeah.
And he said, "Could you give me a piece of chalk?" And the manager went and got a piece of chalk out of the conference room. And Carnegie wrote on the floor of the factory, 1. And then he drew a circle around the 1. Plant manager said, "Well, what the heck is that?" and he said, "You are producing 1 ton of steel a day. If you measure and you just track against tons per day, you will end up improving the performance of your plant." So he picked one clear metric that was easy to communicate to everybody in the organization. So everybody had a clear understanding of what that 1 meant and could use their good judgment and common sense. Empowering employees to use their good judgment and common sense is the secret to business success. And communicating a clear, crisp, easy to understand target, then you or I, working in any company, if we know that 1 is the number and we want to get to 1.1 the next week, we can, the way we spend our time can help reinforce the efforts to get to 1.1. Yeah. You are empowered. You don't need to be micromanaged. You have the ability, because you were able to clearly understand the metric, to contribute your part. And far be it from me as a boss to tell you how to get to 1.1. I expect you to get to 1.1 and use your good judgment and common sense to take the actions to help everybody reach that. That's sort of a operating culture.
Excellent. And that's what you applied in many of your previous jobs?
Yeah. It came out, I grew up on a farm, and it was, how many oranges were we able to haul to the market, and how many crates? It was always a measure. And I knew exactly, from the time I was 8 years old, whether I was helping increase the number of boxes of oranges or not.
Okay, wonderful. Excellent. Hey, as always, I would like to close the session today with the final question, which is, what does it take to get solar to the next level? So we already talked about the regulatory aspects, and you brought in consistency. Is it number 1? And if it's number 1, then what would be number 2?
What I think is important here is the autonomous grid, so that the pieces that we each can bring, in a way, it's similar to Andrew Carnegie, and a clear way of having the decision-making be automated, like autonomous vehicles driving, getting autonomous electrons to go where they need to go. The technology pieces, the scaling, the market is what helps drive the manufacturing side of the business. So what can we do to enable the market for our technology to be faster adopted and incorporated into the grid? Those are the hurdles that will help open up the demand for product to go into that market. That's for me, the next level. The next level is letting the grid network function without human intervention.
Yeah. Yeah. Excellent. So smart grids, right? I think that's the headline for what you mentioned.
Yep.
Excellent, Charlie. It's been a wonderful ride through your past and present solar journey. Thanks a lot for coming onto the show.
Well, thanks for the invitation. It's fun to see you, Torsten. It's been a long time.
Yeah, it's been a long time, and all the best with Galaxy Energy and all the other interesting, fascinating projects that will come for you in the future. Thanks a lot.
Thank you so much, and good luck to you as well.
Thanks.
Take care. Have a good day.
Thanks. Excellent.